In this lecture, we will discuss a corollary of the theorem that we discussed in the previous video. Also, we will discuss a problem of non-homogeneous wave equation. Consider the Cauchy problem for non-homogeneous wave equation utt minus a square into uxx equal to f of xt, and with these conditions, initial conditions. Suppose the initial data f of x and g of x are even functions, and also if the function capital F, that is the external force capital F, is also an even function as a function of x, it's also even as a function of x, then the solution u is also an even function as a function of x. U of xt is also an even function as a function of t, as a function of x. Okay, that is, if these functions, the initial conditions, that is initial data f of x and g of x, and this external force is also even functions, then the solution is also an even function with respect to x. Okay. Similarly, we have these functions are if these functions are odd functions, then the corresponding solution is also an odd function. Or these are periodic functions, then the corresponding solution is also periodic function. Okay, so this is described in the corollary of the theorem last we proved. Okay, so the corollary is actually the statement is, suppose that f comma g are even functions, and for every t greater than 0, the function f, capital F, is also even. Okay, then for every t greater than 0, greater than or equal to 0, the solution u of the Cauchy problem 1, Cauchy problem 1 means this. Okay, this Cauchy problem is also even. Okay, that means if f, g and capital F are even functions, then solution u is also even function. Similarly, the solution is an odd function or a periodic function with a period L as a function of x if the data are odd functions or periodic functions with the period L. Clear? So, how to prove this? So, suppose that uh, f comma g and capital F are even functions. That capital F is with respect to x, as even function with respect to x. Okay, and let u be the solution of the Cauchy problem. Let u be the solution of the Cauchy problem 1, this Cauchy problem. And now define, so we have to prove that u is also an even function. Okay, with respect to x, that is, we need to prove that u of minus x t is equal to u of x comma t. Okay, so we are assumed that f, g and capital F are even functions, then and let u be the solution of the Cauchy problem 1. Okay, now define a function v of xt equal to u of minus x comma t. Okay, so we are defining a function v is equal to, that is, v of xt equal to u of minus x comma t. Therefore, we have the first derivative v of vx of x comma t is equal to ux of minus x comma t into minus 1. Okay, and vt of x comma t is equal to ut of minus x comma t into 1. Okay, and the second derivative is are given by Vxx is equal to the derivative of this with respect to x, that is minus uxx of minus x comma t into minus 1. So this is plus, and Vtt is actually is equal to utt of minus x comma t. Okay. Now, so we have Vtt minus or Vtt of x comma t minus c square into Vxx of uh, x comma t, which is equal to Vtt is actually utt of minus x comma t minus c square into Vxx of x comma t is nothing but uh, uxx of minus x comma t. Okay, so we know that this is actually we know the solution is the u satisfies this differential equation because u is the solution of this Cauchy problem. So utt minus c square into uxx equal to f of x comma t. So we have this is u of utt of x comma t minus c square into uxx of x comma t is equal to f of x comma t. So by using that we have utt of minus x comma t minus c square into uxx of minus x comma t is nothing but f of minus x comma t. Okay, but we are given that f is even with respect to x, so this is nothing but f of x comma t. Okay, it is for minus infinity less than x less than infinity and t greater than 0. Okay, therefore v satisfies the non-homogeneous wave equation. Okay, therefore V is a solution of the non-homogeneous wave equation. Okay. Now, what about the initial conditions? Now, V of x comma 0 is actually is equal to, we have V of x t equal to u of minus x comma t. So v of x 0 is equal to u of minus x comma 0, which is equal to f of minus x. We are given that u of x0 is equal to f of x. So u of minus x comma 0 equal to f of minus x. Since f is an even function, we have this is equal to f of x. Okay, and the second condition is actually vt of x0, which is equal to u of minus x comma 0, sorry, ut of minus x comma 0, which is nothing but g of minus x, which is equal to g of x, because g is also an even function. So v also satisfies the initial conditions. Okay, uh, that is v satisfies the initial conditions of the initial value problem 1 or the Cauchy problem 1. Okay, therefore v is a solution of the Cauchy problem 1. Okay, but that is v of v is actually v of x comma t is actually u of minus x comma t. So this u of minus x comma t is also a solution. Okay, but we know the solution of this Cauchy problem is unique. Okay, okay. So we have v of x comma t is equal to u of x comma t. Okay, now since uh, the solution of the Cauchy problem is unique, we have the solution v of xt is nothing but u of xt, because u is a solution, u is the solution of the Cauchy problem, and we here we proved that v is also a solution, but we know v is nothing but u of minus x comma t, minus x comma t equal to u of x comma t. Therefore u of x comma t is an even function. The solution u of x comma t is an even function as a function of x, or with respect to x, as a function of x. So we have proved that if small f, small g and capital F are even functions of x, then the solution is also an even function. Okay, similarly we can prove that similarly we can prove that if f comma g are odd functions and f is an odd function with respect to x, then u of xt is an odd function. Okay, next we can discuss a problem. Solve the following Cauchy problem. Utt minus 9uxx equal to e power x minus e power minus x for minus infinity less than x less than infinity and t greater than 0. U of x0 equal to x and ut x0 equal to sin x. So uh, here c square is 9, so our c is equal to 3, and these functions x is an even odd function, sin x is also odd function. Now what about this function? This is also an odd function. Okay, because e power minus x, this is e power minus x minus e power plus x. This is actually, this is f of if this is capital F, so capital F of minus x. When we replace x by minus x, we have this is equal to this. So this is nothing but negative of e power x minus e power minus x. So which is equal to minus of f of, okay, f of x. So this is an odd function. So all these three functions are odd functions. So by the previous corollary, we will have the solution is also an odd function with respect to x. Okay, so to solve this Cauchy problem, this is a non-homogeneous Cauchy problem of non-homogeneous wave equation. So by D'Alembert's formula, we have the solution is nothing but u of x comma t equal to 1 by 2 into f of x plus ct plus f of x minus ct plus 1 by 2c into integral x minus ct to x plus ct g of s ds plus 1 by 2c into double integral over delta, that is t from or tau from 0 to t and zeta from x minus c into t minus tau to x plus c into t minus tau f of zeta tau d zeta d tau. Okay, here we have this is capital F, this is small f, and this is small f of x, and this is small g of x. This is capital F of x comma t. Clear? So replacing these functions we will have, and here c equal to 3. So we have this is nothing but 1 by 2 into f of x plus 3t plus f of x minus 3t plus 1 by 2c, that is 1 by 6 into integral x minus 3t to x plus 3t g of s ds. G of s is nothing but yeah, we are right, g of s ds plus 1 by 2c, that is 1 by 6 into integral this. Okay, so to from 0 to t zeta from x minus c into t minus tau to c is actually 3, so we have x minus 3 into t minus tau to x plus 3 into t minus tau of f is actually f of zeta tau d zeta d tau. Okay, so replacing the functions small f, small g, and capital F, we have f of, we have small f is nothing but x, so f of x is small x, so f of x plus 3t is nothing but x plus 3t plus f of x minus 3t is x minus 3t plus 1 by 6 into integral x minus 3t to x plus 3t. Here g of s, g is equal to sin x, so we have sin s ds, sin s ds plus 1 by 6 integral tau from 0 to t zeta equal to x minus 3 into t minus tau to x plus 3 into t minus tau into f of zeta comma tau. Here we have f of x comma t is nothing but e power x minus e power minus x. So f of zeta comma t is nothing but e power zeta minus e power minus zeta. Okay, d zeta d tau. Clear. So this is equal to 1 by 2 into this is actually we can cancels 3t, so 2x by 2, that is x plus 1 by 6 into integral of sin x, sin s is minus cos s from x minus 3t to x plus 3t plus 1 by 6 into integral tau from 0 to t. Integral of this is actually e power zeta. So or we can write this is actually 2 into uh, 2 into is e power zeta minus e power minus zeta divided by 2. So this is sin h of zeta. So 2 sin h of zeta. So the integral of sin h zeta is nothing but cos h zeta. So here we have 2. So 2 into cos h zeta from x minus 3 into t minus uh, tau to x plus 3 into t minus tau into d tau. So this is actually uh, equal to x plus or x minus 1 by 6 into cos x plus 3t minus cos x minus 3t plus 1 by 1 by 3 into 2 by 6 is 1 by 3 into integral tau from 0 to t cos h of x plus 3 into t minus tau minus cos h of x minus 3 into t minus tau d tau. Okay, now this is equal to x minus 1 by 6 into cos x plus 3t is equal to cos x cos 3t minus sin x sin 3t minus cos x minus 3t is nothing but uh, cos x cos 3t plus sin x into sin 3t plus 1 by 3 into integral of cos h of this, that is sin h of x plus 3 into t minus tau with respect to tau, that is minus 3 divided by minus 3 minus integral of cos h of this, that is sin h of x minus 3 into t minus tau divided by uh, plus 3 from tau from 0 to t. So this is nothing but x minus 1 by 6 into cos x cos 3t minus cos x cos 3t minus sin x sin, so this is cancelled, and minus sin x sin 3t minus sin x sin 3t, that is 2 sin x sin 3t. So x minus 2 by 6, that is 1 by 3 sin x. So here is minus, so plus 1 by 3 sin x sin 3t. Now plus we can take negative 1 by 3 outside, so we'll have negative 1 by 9 into sin h of replacing tau uh, equal to t, that is sin h of x plus 3 into 0, that is, and replacing tau equal to t, that is t minus t, that is 0, so sin hx, we have sin hx minus, here is sin h of x. Okay, replacing tau, tau equal to t, and minus the lower limit is tau equal to 0, that is minus sin h of x plus 3 into t. Now minus minus, that is okay, here is plus, actually we are taken negative 1 by 3 outside, so this is 10 plus, and here also negative this, negative sin h of x minus 3t, right, x minus 3t. Okay, when tau equal to 0, so this is actually x plus 1 by 3 into sin x into sin 3t minus 1 by 9 into sin hx plus sin hx, that is 2 sin hx minus expanding sin h of x plus ct, we have sin hx into cos h 3t plus cos hx into sin h 3t minus expanding sin h of x minus 3t, we have sin hx into cos h 3t minus cos hx into sin h 3t. So this is nothing but sin minus sin hx into cos h 3t plus cos hx into sin h 3t. So we have here uh, x plus 1 by 3 into sin x into sin h 3t, or sorry, sin 3t minus 1 by 9 into 2 sin hx minus sin hx cos h 3t minus sin hx cos h 3t, that is minus 2 sin hx cos h 3t. Now here is minus cos h sin h 3t, so plus cos h sin h 3t is cancelled. Okay, so this is equal to x plus 1 by 3 into sin x into sin 3t minus 2 by 9 into sin hx minus, sorry, plus 2 by 9 into sin hx into cos h 3t. Okay, so this is our solution u of xt. So for all t greater than or equal to 0, we have this u of x is odd function in x, because this is odd function, sin x is odd function, sin hx is odd function, and this sin h is also odd function. So u of xt is an odd function of x. Okay, that is because our data f of x, sin x, and this f are odd functions. Okay.